You know, when we send our traffic, our data on the network, maybe due to some reasons our data is corrupted. They do not get data correctly. For example, sometimes you might have seen that some file was sent to you, but when you try to open the file, it says to you that the file is corrupt or and cannot be opened. This may be due to the network. There can be other reasons as well, but definitely we understand while sending our data on the network, data may be corrupt due to many reasons. Because we are converting data from into many formats, we are assembling, reassembling, making frames, dividing, defragmentation, then making the packets again and again. So all this processing, maybe something bad happens and data is corrupted. The question is, how do we detect if data has been corrupted or not? And if we are able to detect, can we correct it? If yes, how can we correct it? This is the two topics of this chapter. First of all, let's study our data detection. In data detection, the first two concepts are the errors. Error means you sent some data, the sender sent this frame, this data, and on the receiver side, some of the bits were changed. So it means there has been some error, changing of the bits while on the network, yani between sender and receiver. This is called a network error. If only one bit of data is changed, only one bit, this is called single bit error. However, if more than one bits are changed, let's say in this example, in this figure, you see how many bits are changed? 4. So this is called burst error. Burst error means more than one bits have been changed. There is error at more than one places. One concept with respect to the burst error is the length of burst. Starting from the first error bit to the last error bit, the distance or the number of bits between the first error bit and the last error bit is called the burst error. Check the first bit of error, it's here. Last bit is here. How many bits are there in between? 1, 2, 3, 4, 5, 6, 7, 8. We count the first error bit as well as we count the last error bit. These are 8 bits. So the length of the burst is 8. Okay, length of the burst is not number of bits which have been changed. You see here 4 bits have been changed, but the length of the burst is 8 bits. Yani this segment has been affected by the error. How do we detect this error? You remember in our wired and wireless communication, in both of these types, the last part of our frames, do you remember? In wired, we had 4 bits of CRC and similarly 4 bits of FCS in our wireless network. At that time, I told you that this is some information that is kept for error detection. This is the time now to tell you how do we detect error. What is this information? How do we make this information? How this information is used to detect error. This is the time and this is the chapter we are dealing with these things inshallah here. Okay, let's understand the error detection, and it is done in several steps and several concepts are needed here. The very first concept is that to detect our error, we need some extra information that we send. In our frames, we were sending this extra information. You see here, this is our original data. Along with our data, we send the source address, destination address, preamble, SFD, and many other things. Similarly, we send an extra information, CRC, along with data to the receiver, and receiver uses this extra information to check whether there has been some error or not. This is the process that is shown in this picture, in this figure. On the sender side, we have a message. This message is passed to a software component. Its name is generator. That generator generates the extra information. Which extra information? This CRC. In wireless, it's called FCS. Okay, so this CRC or FCS is generated and it is sent along with the message. Message plus CRC, these are sent on the receiver side. On the receiver side, receiver receives message plus redundant information. I will call it extra information. Extra redundant means extra. It's easy to speak, just for the sake of ease I will say extra, otherwise we can say redundant. On the receiver side there is a software component, its name is checker. The checker, it checks the CRC and uses the CRC. If it checks that the message is, how it uses the CRC I will explain you later. I will explain you later how it uses CRC. Let me see. Wait. Okay, I can tell you right now. I think I should tell you right now. It checks the CRC and if it finds there is no error, it checks the message. Okay, and if there is some error, first of all, we will see if we can correct error. If we can correct error, error will be corrected. If we cannot, then we discard the frame which is in which we find some error, maybe a single bit error, maybe burst error, whatever. We will discard that frame and we will ask the sender to please send that frame again. Okay, this whole, first of all, this component is called checker and this whole process is called decoding. Yani receiving the message, checking it, if it is correct, then accepting the final message and discarding the extra information or redundant information. Yani this CRC is for checking only. Then after we will discard it. This FCS is the same. Okay, this whole process is called decoding and it is done by a software component. Its name is decoder. This whole process is called encoding and the software component um, that does this encoding is called encoder. Encoder or encoding is done on the sender side, decoding is done on the receiver side. Now I give you one example how this extra information is generated and how it is used. Let's say I want to send to you a message which is salam, SLAM, salam. I send this to you. So I am the sender. Salam will go to the generator and generator generates a number. Let's say this number is 4. Somehow generator used some algorithm and calculated a number 4. So my message salam and this redundant information 4, it will be sent to you. You received that information. What did you receive? Salam and 4. Okay. The checker will again take salam and generate the extra information again, like on the sender. Sender took salam and generated the extra information which is 4. Checker will do the same thing again, take salam and generate the extra information. Now the checker, if the checker also generated 4, which he will compare it with extra information that I sent to you. My extra information was 4. If on your side checker also generated 4 from salam, he will compare 4 with your 4 with my 4. If these are matching, yes, these are matching. Your decoder will think that there is no error and your decoder will accept the message salam. Let's say now we can consider a second case. In second case, what happened? That I sent you salam and 4, but you received SLEM, not SLAM. One of the character was changed. Okay, so that changed character, checker will take this word and generate the extra information. Now extra number for salam was 4, but for salam, SLEM, it will be a different number. Let's say it is 3 or 5. Now extra information generated on your side will not match the extra information that I sent because the message now is changed. On here I wanted to send you SLAM, salam, but you received due to some error SLEM. Of course, your generator here will not generate the same number because the text is different, data is different, so extra or redundant information will be different. It will not match with what I sent to you. Okay, I'm telling you that along with our data, we send some extra information. Okay, why do we send some extra information? For error checking. This extra information is used by the receiver to check if there was some error. Okay, in our wired network we use a different algorithm. In our wireless we use a different algorithm to generate extra information. This extra information is sent with data. Let's see here, this is me. I want to send you a message. Okay, let's say my message is salam or how are you. Let's say now I generate a message, how are you. I want to send this how are you to you. First of all, I will generate the redundant information or extra information or error checking information that I will send my message. My message is how are you. I pass this message to a software. That software, its name is generator, and it will generate the redundant information or error checking information for me. Let's say it generated 9. Okay, it generated 9. So I will send you how are you and 9 to you. You will receive how are you and 9. If everything is fine and you exactly receive the same thing, how are you and 9, this is the first case. Second case, maybe something is changed. 9 may be changed, it becomes 10 or 8 or 7, or how are you is changed and it says who are you due to some network traffic. Okay, both we will study both cases. So whatever the message is received, on your side there is a software. It is called checker. First of all, checker will generate the extra information from the message. If message is the same, it will generate the same number 9, and it will compare the number generated with the number that I sent to you. If you generated the same number which I sent to you, it means the message is the same, because for the same message, same number will be generated. For a different message, different number will be generated. If message is the same, you will generate the same number and you will compare it with my number that I sent to you. If both numbers are same, you will say that message is okay, there is no error. If your number generated here is different, then you will say, and you compare it with my number and you find that both of these numbers are not same, different, then you will consider that message has been changed on the network. Maybe message is changed, maybe number is changed. Anyway, your extra information, your error checking information, error checking code will not match with my code. Okay, in that case, if it does not match, you will discard the message and you will ask me to send that frame again.